let's just consider a specific example. Let's say we've got a ball of mass 2 kilograms and it's moving in a liquid where the drag force is -4 newtons per meter per second multiplied by the velocity. That means for every meter per second of velocity, this thing experiences a drag force of 4 newtons in the direction opposite its motion. And let's assume initial velocity is 3 meters per second. Suppressing the units, we can write the net force as -4v. Considering velocity to be a function of time, we write the equation 2 dv dt equals -4v, and that's easily solved. We get v of t equals a e to the -2t, provided v is greater than 0. Applying the initial condition, this tells us that v of 0 equals a e to the -2 times 0, which is a, and of course v of 0 is assumed to be 3 meters per second, so that 3 equals a, and our velocity function is 3e to the -2t. Now this is going to be an exponential function. It's going to fall rather rapidly. We're going to be down to e to the -2 after 1 second, e to the -2 being about 1/7. So we're going to be down to about 1/7 of our initial velocity after a second. Excuse me. Applying our initial condition to the velocity function of x, we find that v of 0 is v naught minus 2x, which means that x would be 0, so I suppose we better put a 0 in there, so that 3 would be just equal to v naught. And our function now is v of x equals 3 minus 2x. So here's our velocity as a function of position. Here's our velocity as a function of time.